Okay, so in this video, I want to show you some quick video about how to use Optuna for hyperparameter tuning on machine learning models. So, what is Optuna? Optuna is an open source optimization framework in Python designed for automating the search for optimal parameters, that is hyperparameter optimization, in machine learning models and general purpose functions. Optuna supports advanced optimization algorithms, parallel execution, rich result visualizations, and easy integration with popular machine learning libraries such as scikit-learn, XGBoost, PyTorch, and TensorFlow. Now, in this video, I want to show you some step-by-step explanation on how you can use Optuna to do hyperparameter tuning. And the machine learning model that we want to use today is Random Forest. Okay. So first thing first, let's import the libraries and load the dataset. So we import Optuna for hyperparameter optimization, and then we load the dataset, that is iris dataset from scikit-learn. And then I want to use Random Forest Classifier for the machine learning model that we want to use today. And then import cross validation and run test split. Okay, load the iris dataset and split the dataset. Next, this is the important part. So we define the objective function. So first we define the objective function where it receives a trial object from Optuna which suggests hyperparameter values with a specified range. So this is actually a range. So it starts with a range from 10 all the way to 100. This is also range from 2 to 10. Okay, and this is the hyperparameter that we can use for random forest. Here we use function trial that suggests int. This is to sample integer values for an estimator and max depth. This is the hyperparameter. This is the number of trees and this is the maximum depth of each tree. And then we built a random forest model using this hyperparameter. So using two hyperparameters, and then the model is evaluated using threefold cross validation, and then we calculate the mean accuracy for the objective score. Okay. Next, we set up and run the Optuna study. So by default, actually, Optuna uses the TPE sampler. So this is tree structure parsen estimator, one of the algorithm from Bayesian optimization. But here we explicitly set the seed for reproducibility. So yeah, I set the seed to ensure reproducible results. And then we create an Optuna study with the goal of maximizing the objective score, where the objective score is accuracy. Okay. And then we run the optimization for 20 trials, meaning Optuna will try 20 different combination of hyperparameters. Next, we retrieve and display the best result. So we can print the details by using study.bestTrial, or if you want to see the important part, such as you want to see just hyperparameters, you can do that by study.bestparams, and you want to see the best accuracy, you can do that by study.bestvalue. Okay. Okay, so let's now check out the full code here. So we import the libraries, we load the dataset, we split the dataset, and then we create this objective function, and then we set the hyperparameter and the range, and then we build the model. We use that hyperparameter, and then we're using cross validation, and then get the mean accuracy, return that objective score, that is the accuracy, and then we set the seed so we can get the reproducible results, maximize the accuracy, and then we set this to run for 20 optimization, and then we print the details, and then we get the best parameters and the best accuracy value. Okay, so if you run this, and it will show the process here, and let's see. It starts with trial 0 all the way to trial 19. Each trial it will print the accuracy that it get. For example, this trial 0 finish with accuracy value of 94%, and then it will print also the parameters that it use. So on trial 0, it tries with estimators 44 and max depth 1. And last, it will print which trial has the best value. Okay, so let's say, let's see. Says best trial is 0, best trial is 0, and then best trial is 2, because best trial on the trial 2, the accuracy is 95%, better than trial 0. Okay, best trial is 2, best trial is true all the way to 15. So best trial is 15, because on trial 15 it has accuracy value of 96%, better than trial 2. And then best trial 15, best trial 15, all the way to trial 19. So it stays at best trial is 15. Okay. So let's see the details here. The details. We get the best trial. That is trial number 15. And this is the details. You don't have to read all of this. This is just, I think this is too much. If you want to see just the hyperparameters, you can see here. So the best hyperparameter is when the estimators is 31 and the max depth is 3. And by using these hyperparameters, you get the best accuracy, that is 96%. Okay, that is how you interpret the output. Okay, so I think for the summary, this workflow demonstrates basic hyperparameter using Optuna, and we use just a sample dataset, iris dataset, and random forest classifier for machine learning model. We optimize two parameters, that is an estimator and max depth, to maximize accuracy, mean accuracy. And then I already set a random seed for the Optuna sampler, so we can ensure that optimization results are reproducible every time I run the code. And the code can be easily adapted to other models, dataset, or additional hyperparameter for more advanced optimization tasks. So yeah, for this video, I only explain you the basic use case for Optuna when you want to do hyperparameter tuning for when you are using machine learning model, because previously uh, you are using grid search or random search, right? So you can use Optuna for hyperparameter tuning, so it gets more efficient and faster. Okay. Okay, I think that's it for this video. Thank you, and I'll see you guys in the next video. Thank you.